Good morning students, I am Vetrichelvi from Vetrichelvi NEET Chemistry. Now I am going to give the video NTA appears by part number 6. Till part number 5 we have completed questions 34. So now let us see the questions 35 onwards. Part number 5 is with the heavy content. Without missing, please go on prepare it. Now let us go to the today's question starts with the 35. For the reversible reaction of Haber's process at 500 degrees centigrade, Kp is given when partial pressure is measured in atmospheric pressure. The corresponding value of Kc with the concentration is moles per liter is answer. That. Okay, now what is given is, in the question what is given is only the Kp is given, temperature is given, they are asking Kc. So what is the relationship is Kp is equal to Kc into RT to the power of delta Ng. So now before going to the thing, they are asking Kp is given, Kc we have to find out. Okay, what is delta Ng is for Haber's process? It is the delta Ng is equal to total number of moles of the gaseous products minus reactant. In the product side 2 and it is reactant side 4, so different is minus 2. So delta Ng is equal to minus 2. This value, that is delta Ng value for the synthesis of ammonia is minus 2 should be in your mind. Such a way the data should be in the fingertips. You should not do here in the examination hall. Okay, now you want a Kc. So what do you have to, the formula is become Kp divided by, this is RT. Now let us write the Kp is, from the sum we are writing the Kp values 1.44 into 10 power minus 5 divided by R is because it is given as in the terms of the atmosphere. So we are taking the R value is liter atmosphere. So 0.082 into the temperature in the sum is given as the 500 degree. To that you add the convert as the Kelvin. What we are having is 773 Kelvin to the whole power. Delta Ng is the minus 2. So before answering, we have a glance on the option. As it is, the option is available. So my answer is matching with the option number B. So now we are simple question now. We are going to the next question. The EMF 36. Let us go to the question number 36. Let us see the question number 36. Which method is used to separate the sugars? Okay, it is very important point, separate the sugar. So your answer is here, it is only sublimation. You know what is the meaning of sublimation. So remaining points are not matching. Here it is very important, it is not a fractional crystallization. For preparation fractional crystallization, separation, sublimation. Now let us go to the question number 37. Okay, the question is here. The EMF of the cell corresponding to the reaction zinc in the hydrogen gives zinc ion and hydrogen, and it is the EMF value in the sum is given as a 0.28 voltage at 25 degrees centigrade. The pH of the solution, the hydrogen electrode is, they are asking what is the pH. What else is given? The reduction potential of zinc and reduction potential of your hydrogen is given. Okay, so at 25 degrees centigrade. So what is the formula we have to use? We have to use the Nernst equation. Now the Nernst equation is available. Let us see the equation. E is equal to E naught minus 0.059 by 2 log of, actually 2 means here number of the electron involved is the, in the reaction it is the 2. So it is taken as a, in here it is the 2H plus. So because of that the number of electron is 2 and the log of Q, that is concentration of product by reactant. Let us write the values. E is from the sum, it is given 0.28 and E naught value. How you have to find out the E naught value, let me write here. What is E naught value is equal to E naught of, that is right minus left. E naught of right minus left. What is your cell is constructed is zinc in zinc 2 plus salt bridge H plus and hydrogen. For hydrogen 0, for this is minus 0.76. In the sum this is left side, this is right side. So now what is my 0? Formula is even this is in, that is right side minus left side. Right side is a 0 minus of your, what is the left side is your hydrogen, that is minus 0.76. Now your answer is minus into minus plus 0.76. What is this? Is the E naught of the cell you have to calculate. And now that value is I am putting here. This is plus 0.76 the E naught value minus that is log of. Here what is written in the equation is written that is the product. What is the product? Is zinc is the product and its concentration is. Zinc is the product and its concentration is 10 power minus 1 into hydrogen is 1 atmosphere divided by the reactant side your H plus is that with the stoichiometry is H plus to the power of 2. So now this is the knowledge we have taken based on the equation. Now our work is to focus on this work. Let us go to the work. Here that is here till this everything is as it is. Now let us see here focus here it is the knowledge. Log 10 power minus 1 and this is into 1 atmosphere same value only minus of log this one denominator minus of log H plus to the power 2 to bring it on here. So here 2 log H plus. So within the bracket don't confuse this one you have this one you put right as in the bracket. Okay, what is the next work I am doing is here in this one. Here this is. What I am doing is this one, this minus 1, the whole part you bring it on the next side. So here you can see minus become your plus and log 10 power minus 1 log 10. So this is and then minus 2 as it is written that is equal to. So the minus is coming here. So now what should be the plus is going on next side as a minus 0.28. Now this is on simplification you are getting 0.48. Now let us see how we are proceeding here. Now here the 0.03 you bring it on the next side to the denominator. So now let us see here what is happening is 0.48 into 100. So 48 by 3 is equal to 16. So this is simplification of this side you are getting. So what is happening here is minus 1. You are writing as it is only. This minus 1 you bring it on the next side plus 1. So 16 minus 1 that is plus 1 you are getting the 17. So what we are having is here only this is only this part only is available here. So now till that we got it. This is the thing. How we have to proceed is this one. Minus you are bringing it on the next side. So it's here it is plus 2 in the denominator. So what are getting is minus 8.5. Now log hydrogen ion concentration is minus 8.5. We want pH. What is the definition for pH or formula is negative log of hydrogen ion concentration is pH. So your hydrogen ion is minus of minus. So it is pH is equal to plus here it is 8.5. Let us go and verify the answers in your question option is you are having here my answer is 8.5. Here it is 8.3. I am selecting as option because here we have round up as a 0.06 and it is taken as a 0.03. So because of the small variation, so we can proceed and that is the answer. Okay. Again children, I am going to repeat here what is the work is they are asking the pH. pH means hydrogen ion concentration you have to calculate, then you have to substitute. So what is the thing is here you have to work it carefully. The remaining part are very simple only. Now let us go to the question number 38. Okay. Arrange the given in the correct order of Lewis acidity in the boron compounds are there. Now what is the definition is given is first point I have given. What is the meaning of Lewis acid? Lewis acid is the acceptor of electron. It has to accept the electron. It has means what I meant is the boron. Boron has to accept the electron means that it having the vacant orbitals. Now in this case what is pronounced is more back bonding. So back bonding influence means the empty orbital available will be decreases. More back bonding, empty availability will be lesser. Now let us coming to our question. These things are there here as it is written. So what is happening here? Small size in this one size is smaller. So this is having the most back bonding. Size is smaller, most back bonding. So most back bonding means vacant orbitals is less. So now what is here it is written is based on the back bonding. What is the next one I have written is Here the sign is simply I have changed. You can see the same. What is this one is indicated for acidity. So now our order is matching with this were option. Okay children. So here what is the first definition? Acid means accepting of electron pair. It has to accept the electron pair, that should be empty orbital. When you will have empty orbital, lesser back bonding, more empty, more acidic. So this is here because of the greater size, lesser back bonding, so it is more vacant orbital, so more acidic. So accept the electron. So this is the way you have to answer it. Now we are going to the next question. Is very simple question. Consider the following structures. You are available with the three structures of that. What they are asking is something related to the dipole moment and the stability. So we have to consider the stability. What are the things you have to find out is aromaticity. From the general organic chemistry, aromaticity is very important knowledge. It is given here. It is a complicated structure. Let us see first one. In this one we are calling as, this is labeled as anti-aromatic. What is the meaning of anti-aromatic? It will satisfy them sp2 hybridization, and then it is the planar, and then what is it is not matching is Huckel's rule. It is not matching. That is called the pi electron is you are having here 2, 4, 6, 8 pi electron, which is not possible. So it is labeled as anti-aromatic. First two rules are matching. Huckel is not matching, so it is anti-aromatic. In this case, it is aromatic. How it is aromatic means the first two cases all are sp2 hybridization, so they are the planar, and the Huckel rule is you are having. To verify the Huckel rule, you need not calculate all the electron. You go and find out the double bond. If the double bond is odd number, it is matching. Now I am having that trick, you follow it. Here 4 double bond even number, not Huckel rule. Here 3 double bond odd number, so it follows Huckel rule. So the number 2 is labeled as aromatic. Whatever happened to the number 3 is, it is labeled as non-aromatic. Why you call it as a non-aromatic mean? You can see children in this corner it is sp3 hybridization, that is tetrahedral, so it is not planar. So initially it is not matching, so it is called it as a non-aromatic. So all the threes are available. So how we are going to give the aromaticity? For aromaticity, what is the condition is? Aromatic is more stable than the non-aromatic, which is more stable than the anti-aromatic. This is the condition. Who is aromatic? Right here 2. Who is non-aromatic? Number 3. Who is anti-aromatic? Number 1. So this is the order of stability. Here it is written here. Order of stability is equivalent to, it is the dipole moment. This is the one condition. Now these are the knowledge. Let us go and see the option. What is the first option is dipole moment rises is 2 is greater than 3, 3 is greater than, there is a correction in the question, no, it is the 1. So this is matching with that, so this statement is correct. Next one is second is more stable than 1. You can see here it is second is more stable than 1. It is correct. 1 is here, it is more stable, 1. And then 1 is the most reactive. It is most reactive. Definitely it is unstable, so it is highly reactive. So that statement is correct. So all the statements are very correct. It is a totally knowledge based and interesting question. Okay, now we are coming to the next one is the number of geometrical isomers that can exist for the square planaris. Here it is, what is it called it as a, here I am giving the representation now. Central metal atom with the 4 ligands are available because all the 4 ligands are different. So since it is different, you are NCERT based question. So when it is for different mean, it is a condition known knowledge. It is able to follow the 2 cis isomer and only 1 trans isomer. Totally you are having geometrical isomer of 3 only. Okay. With that I am closing this lesson, what is video, remaining we will see in the next video. Thank you children.